Good afternoon, everyone, and welcome to the next chapter in our series of aquaculture-related webinars designed to bring together science and business to expand and strengthen the United States aquaculture industry. These webinars are a joint effort between the National Aquaculture Association, the North Central Regional Aquaculture Center, and the United States Aquaculture Society. Whether you're currently engaged in aquaculture, looking to get into business, an educator helping others understand aquaculture, or just want to become a better educated consumer, we hope these webinars will enhance your knowledge and move you forward on your journey to success. Today's webinar is entitled Recreational Fish Pond Management and will be presented by Dr. Jay Shelton, an Associate Professor of Fisheries and Aquaculture at the University of Georgia. Jay has over 25 years of experience in pond management, dating back to his days as a fisheries graduate student at Auburn University. He teaches fisheries management in the Warnell School of Forestry and Natural Resources and has presented hundreds of workshops and seminars on the subject of recreational pond management, authoring publications on various aspects of fisheries management, including aquatic plant management and water quality management. Jay will help you understand the finer points of managing a recreational pond for angling and aesthetics to produce that trophy fishery you always wanted. And don't forget to tune in at 3 p.m. Eastern Time on August 17th, when Ron Kinnunen will cover the Hazard Analysis and Critical Control Point, or HACCP approach, to preventing the spread of aquatic invasive species. And with that, I'll turn it over to you, Jay.
All right, thank you, Alan. I hope everybody can hear me now. Hope we've got all the technology working. We've got quite an ambitious task ahead of us in that the subject of pond management is pretty complex. And what we're going to try to do today is just to hit some of the high points in a general sense. And I have a plan to do that by first talking about a few specific topics that will include pond construction and pond renovation, fish ecology, principles of aquatic plant management, and then water quality management. And then the second half of today's webinar will hopefully have an interactive discussion, some troubleshooting, try to answer any specific questions that you have. So if you have any questions, you can jot them down during the first part of the presentation, or you can actually input them via the Zoom software, and then we can discuss them after the initial presentation. So I'm going to start by just kind of going through chronologically some of the basic elements of successful pond management. Obviously, you start with planning and design, and then good construction practices. But these practices need to be based on some sort of a stocking strategy or a set of objectives that you hope to accomplish. And these are really important to assess and to consider prior to taking any other actions. Successful pond management also involves a basic understanding of fish growth and also the value of harvesting fish as a management tool. There's some basic ecology involved in terms of understanding fish reproduction for various species, in terms of understanding the population dynamics when you mix different species together. Some basic ecological principles like the principle of recruitment, predation, and competition. Successful pond management also involves an ability to accurately assess and monitor the fish stocks. So we have to have some mechanism or tools for determining whether things are proceeding and are likely to be sustainable. We also, in addition to monitoring the fish stock, we also need to be able to monitor the environment, the water and the habitat in which the fish are growing to assure sustainable management. So this concept of defining your objectives seems so simple, but it's not always that simple. But if we think about this idea of quality fishing, what does quality fishing mean? Well, it means a lot of different things to a lot of different people. So in my mind, I might say something like, I just want to take my daughter fishing with a very high rate of quality harvest. But there's that quality term, and that's sometimes a little bit difficult to quantify. So this concept of quality fishing can be species dependent. There are certain species of fish that some people prefer over others, so the selection of species is critical. Can be size dependent. The size of the fish that are considered to be desirable is not always the same for everyone. And then these two related terms, abundance or the density of fish, how many fish are present in a given body of water, and then the rate of harvest, catch rate, are very closely related. So lots of fish, a high catch rate, fewer fish, a lower catch rate, but you might have a higher likelihood of catching big fish. And this whole concept of what is a trophy, even that is not always well understood. But I use an example here from the southeastern United States. But I want to say here that oftentimes we're just talking about predators. We're talking about some predator species. Here it would be a largemouth bass. In another part of the country, it might be a smallmouth bass. It might be another species. But down here, it's oftentimes that big trophy bass that everybody is looking for. And here's an example of a fish that was caught locally, a 25.5-inch largemouth bass. Many people would think that's just an awesome, awesome fish and be absolutely thrilled to catch that fish. But take a look at this fish. This is another 25.5-inch largemouth bass. So both fish exactly the same length. But I think you'll agree there's some obvious differences between those two fish. This first fish has a much larger head in relationship to its total length. This second fish, a much smaller head in relationship to its total length. So even though the two fish are both exactly the same length, the quality is arguably different between those two fish. So that's one of the things that we need to consider. Now, as we proceed chronologically, obviously the place to start is by either building a pond or in some cases renovating an existing pond. So this whole area of planning and design of a pond with sustainability, meeting our objectives for multiple generations to come is very critical. There are in existence and have been constructed over a period of decades, many thousands of ponds on both private and public lands that are used for primarily fishing or for a combination of objectives that includes fishing and potentially other things, livestock watering, irrigation, etc. But there are many, many ponds that dot the landscape in some states and in some regions, many more than others. However, in recent years, the federal and state and local regulations have made the construction of new ponds far more difficult, far more expensive, lots more red tape than there ever was before. And so that's something to consider in this whole area of pond management. Because one of the things that's done is it's made existing ponds very, very valuable as a resource. So when managed properly, existing ponds are something that can be worth a considerable amount and worth investing in, even if the pond is pretty old, is in fairly bad shape, and might be in need of renovation. So if we stay within that footprint, it's oftentimes much, much cheaper and much easier than it would be to construct a brand new pond. And that's another important consideration. Well, the subject of pond construction and pond renovation is very complicated and can take a long time to explore, but we can't go into it today, but I want to just give you a few resources. So what I'm going to try to do here is to switch to an online resource. The regional aquaculture centers all over the United States, funded and managed by the U.S. Department of Agriculture, are an available resource, and we can provide you with these links. But this link shows you a list of fact sheets of very applied information on the subject of pond construction. So for example, if we're interested in renovating a leaky pond, we could choose one of these fact sheets. We can download that information and we can take some time to read it over and to get a better appreciation. So that is something to consider as we, if we want to get into greater detail on the subject of pond renovation. But as I mentioned, things are kind of complicated these days. So there are numerous laws, there are numerous agencies which regulate pond construction, and they include, but are not exclusively, the U.S. Army Corps of Engineers and the USDA Natural Resources Conservation Service, the NRCS. There are also state departments. Here in Georgia, it would be the Department of Natural Resources Environmental Protection Division, but there are other agencies with different names in other states. Then there are also local ordinances. So it's a good idea to try to get some local information that's appropriate to wherever you live. And so as an example of that, if you lived here in Georgia, you can go online to the NRCS website and you would find a publication called Building or Renovating a Pond in Georgia, a guide for citizens. So wherever it is that you're thinking about constructing a pond or thinking about renovating a pond, I would go to the NRCS website and find the closest office. And that's oftentimes a good place to start, because they can link you to these other federal agencies, local ordinances, and try to get the ball rolling in terms of making sure that you followed all of the regulations. All right, I want to shift gears here. We talked a little bit about construction, but then once you build it, the bottom line is that a pond is indeed an ecosystem. It is an artificial, and it is a highly simplified ecosystem, but all of the ecological principles still apply. So I just want to explore a few of these ecological concepts, because it's more useful in a generic term, because we're going to be talking about different species and different stocking ratios in different parts of the United States, but some things hold true regardless of where you are. One of those is this rather simple equation here. You see light plus nutrients plus optimal temperature means some plants will grow. And the real question is not will they grow, but what is going to grow? Is it going to be the things that we depend on, the things that are desirable, including phytoplankton, which is basically the microscopic algae that imparts that greenish color to water, the things that sometimes in ponds we call a bloom. We say we have a good bloom on this pond, then it should be productive and we should expect good quality fish production. Or is it going to be something that's less desirable and less usable by fish? As an example of that, filamentous algae, which goes by many names depending on where you are, but it can be stringy and slimy, it can be stringy and woolly, but it's not something that is going to directly translate to growing more fish. Other types of plants include what we call macrophytes. These are the things that are big enough that we can see them with the eye, the things that have the typical plant parts like leaves and stems and roots and flowers. Macrophytes come in two forms. The desirable macrophytes, the desirable plants that are usually native and don't tend to become a problem and can provide good habitat for fish, or the undesirable macrophytes, which are often invasive exotic species of plants that have invaded the US that are not native and can cause some extreme problems under many circumstances when we are dealing with fish management. So it's also important to consider whether it's invasive and likely to be a problem, or if it's desirable habitat when it comes to macrophytes, when it comes to plants. So primary production is then converted into something, some sort of an animal. Oftentimes that animal is consuming that primary production, and then it grows, produces more flesh. There are a number of different fish that can directly convert primary production into fish, but there are also important invertebrates in pond systems that consumption can produce things like crawfish, things like aquatic insects, which are good fish food, or it can produce small fish, which are also good fish food for the predators in the pond. So we got production and we got consumption, and all together we must consider another important concept, and that is carrying capacity of the pond. And in our case, because we're talking about pond management for fishing, we're most interested in carrying capacity for fish. And that's simply the maximum sustainable density of fish that we can expect to support in a given unit of water. Oftentimes we'll use hectares or acres, some other type of surface area unit. But the important point here is that carrying capacity is extremely variable. There are some parts of the country, the Piedmont, for example, of Georgia, or the Piedmont of the Southeast, where natural carrying capacity can be very low. There are other parts of the country where natural carrying capacity can be quite high. So it can range, I put the ranges of 40 to 400 pounds per acre, but it can go higher than that. But it's important to understand what the expected natural carrying capacity in your given area is, and in order to effectively manage a pond. And once we understand that, then we can talk about how that carrying capacity is split up, how it's split up within the different types of fish that we would have in our pond. And ecologists like to use names and lump things into categories. And for our purposes, we can think about three different categories of fish. The things that we would consider to be predators. The term piscivore would be the fish-eating fish. Things like bass, largemouth or smallmouth bass, things like walleye, things like adult crappie would all go into that predator category. And the next category are the things that we would think of as fish food. Sometimes in pond management, we use the term forage or prey. So these are the fish that can be desirable in their own right in terms of harvest for food or in terms of recreation, but they also provide food. They are fish food for the predators, which sometimes are the prime focus in pond management. Things like bluegill or yellow perch, and then which are of course desirable in themselves, but also can provide fish food, and others like minnows and shiners or shad or herring, which can also provide prey or forage for the predators. And then can kind of lump everything else into the other category, and that would include things like omnivores, such as channel catfish, or herbivores, which in some states, the use of grass carp for aquatic weed control would also fall into that category. Now, again, I mentioned this before, but it's worth reiterating that specific stocking regimes have been researched in great detail for every region of the United States. And so it's best to consult the local fisheries agency that deals with fisheries management to get that local recipe, to get that local stocking regime, because that's much more appropriate than what I might discuss or what might be considered to be generic across the entire United States. So as an example of this, I'm going to try to graphically represent this in terms of two ponds. So we've got two ponds, one with a high carrying capacity. So basic local conditions are such, the primary productivity is high, and the carrying capacity of pond A, you see here, 475 pounds per acre is what we could expect to grow per year in that pond. So it's got a relatively high carrying capacity compared to pond B, 215 pounds per acre per year. So you can think about carrying capacity as a pie. So the overall size of the pie can be large if we have great carrying capacity due to local conditions, or it can be small if we have lower carrying capacity due to local conditions. The other important thing to consider is how the slices of that pie are subdivided. And so in the example, pond A has a population of largemouth bass, the blue slice of the pie of 75 pounds per acre, and it has a population of bluegill of 250 pounds per acre, and a population of catfish of 150 pounds per acre. So in terms of ecology, we think about the prey species, the food species, which would be our bluegill in gray, and we think about the predator species. In our case, it could be largemouth bass. In another part of the country, it could be another predator species. But you see the blue slice of the pie. And the point here is that in pond A, the ratio of available food or prey to predators is low. It's 3.3 to 1, whereas in pond B, the ratio of prey or food to predator is 10 to 1. So the largemouth bass in pond B have much more to eat and would be expected to be in greater condition and to grow faster than they would in pond A, even though the overall carrying capacity of pond A is much greater. So as an example, and only as an example of one specific recipe that is commonly used here in the southeastern United States, and again, this would not apply in Iowa or Minnesota, but that information is available at the local level. But just to give you an example of how you put all this together, here is one recipe commonly used to produce sustainable fishing here in the South, in the Southeast. Oftentimes we'll stock 100 largemouth bass fingerlings per acre, and then in combination with 900 bluegill per acre. Now, you might think about this in terms of which would you stock first. Well, obviously, in terms of chronology, you've got to stock the food before you stock the predator. So you would start by stocking the bluegill in the pond, and once those bluegill have started to spawn and produce fish food, you would stock the largemouth bass, and they would eat the fish food that was being produced by those bluegill. So we oftentimes think of whatever our forage or our prey species is, whether it be yellow perch, whether it be threadfin shad, whether it be bluegill or some other prey species, as a food pump. We expect it to continue to reproduce and to keep pumping food into the system that is utilized by our predator species, whatever that might be. And again, lots and lots of diversity in terms of choices, but it's not something that you should choose randomly. It's very important because most parts of the U.S., a lot of research has been applied to coming up with the right combination to what is sustainable and what works well. And so that's something you should definitely consult your local fisheries biologist about. All right, so once we've got it stocked, how do we evaluate or how do we assess whether things are working right? So first, graphically, I've tried to depict this here. Obviously, we've got two fish here, one in what we consider very good condition, a nice big plump fat fish, and one in very poor condition. And so these are kind of your extremes. But in terms of understanding and assessing a fish population, the dynamics of a fish population, and whether things are balanced, and by balanced, I mean they're going to be sustainable, we use a couple of concepts. One is the concept of standard weight. The other is the concept of relative weight. And standard weight can simply be thought of as, for local conditions, how much should a fish weigh for its length? So if it's 15 inches long in Idaho, how much should it weigh? And that kind of data is oftentimes available from the local fisheries biologist. And I'll give you an example of how that can be used. But here you'll see this blue line, which basically means that for a given length of fish, what should it weigh? What should the growth be as a fish gets longer? How much bigger in terms of mass should it become? And so as an example of this, if we were to obtain this standard weight table, which we can do for most parts of the U.S. From a local fisheries biologist, it's available online from a lot of sources. You'll see here on the far side of the screen, largemouth bass standard weights. What should they weigh? Well, if a largemouth bass is 15 inches long, it should weigh 1.8 pounds here in the southeastern United States. Again, this is regional, and so you should use local data. And so we can use that standard weight to assess any sample of fish that we collect from the pond, whether it be fish that we caught or whether it be fish that we harvested by some other means. And so in our case, say we catch a 15-inch largemouth bass and it weighs 1.5 pounds. We use the standard weight table. We see what it should weigh. We divide its actual weight by its standard weight, and we see that it weighs 83% of the standard weight. In other words, it's underweight. It should weigh more. It's not in ideal condition, which is it suggests that we have an issue with balance. And we can take this information for whatever our primary predator might be in the pond, for whatever our primary forage or prey might be in the pond, and we can use it to assess whether we are in a balanced condition where both are have good relative weights, or whether we've got crowding or competition on the forage side, as depicted in the upper right, or we've got crowding, on the forage side as depicted in the lower left, or on the predator side as depicted in the upper right. So this information on relative weights can be used to evaluate specific circumstances in a pond, and here are a few examples of how that can be used. We take our standard weight information, and you see that's depicted by the blue line, and then we take the weights of individual fish. You see that most all of these fish fall right along the relative weights, and that would suggest that this is a balanced pond, that fish of all sizes, from the very small fish to the larger fish, are all getting plenty to eat. So that's an optimum circumstance. On the other hand, if we plot that data, if we take those relative weights, we don't have to plot it, but we can compare it to the table, and we find out that all of the numbers are below the standard weight, as depicted by this example, we would consider that to be an unbalanced condition, and we'll be concerned about the sustainability of our predator-prey interaction, of the balance between our food and our predators in that pond. Often it's a little bit more complicated than that, in that it is size dependent. So here's an example of some real data where you see the small fish in this pond are getting enough to eat, and they're doing fine. But when fish get up to be about 13.5 or 14 inches, they don't have enough available food. And so up to about 20 inches, all of the fish are in poor condition. And then when they get up much larger, a larger fish has a bigger mouth. Bigger gape size means it's got more available items to eat. You'll see that the condition of the largest fish in the pond or much better. And so this kind of tells us how we fine tune our management, what we need to focus on in terms of harvest or in terms of other types of management activities to provide fish with what they need to stay in that balanced area. So I mentioned earlier that balance means sustainability. And a part of sustainability inherent in fisheries management is oftentimes harvest. Harvest can be one of our most valuable tools in terms of long-term maintaining balance or long-term maintenance of sustainability. So here's just some examples of a stocking ratio and a harvest recipe. The traditional balanced stocking ratio is one for the southeastern United States. Again, you'll see that 10-to-1 ratio in terms of forage, or in our case, down here, it would be bluegill and red ear. In another part of the country, it might be other types of forage. To predator, in our case, that would be largemouth bass. That 100 largemouth bass fingerling stocked per acre, 1,000 forage fingerling stocked per acre. And that's a very traditional recipe. And you'll see the harvest rates. The important thing about these harvest rates is you'll notice that the total harvest needs to be split up proportionally between the prey species, in our case, the bluegill and the red ear, with very high rates of harvest, and the predator species with much lower rates of harvest. Now, I also put on here for our discussion today this what's called a trophy recipe. Here in the Southeast, we oftentimes try to grow trophy bass, but if you're trying to grow a trophy in another species in another part of the U.S., the same concept would apply. We've simply added much more available food for every available predator in that pond. You'll see that there's a much higher ratio of forage to predator in the trophy scenario, and there's also a lower amount of harvest in the trophy scenario. And again, this is just one example for our discussion, but you could just think of it in a generic sense in terms of this balance in terms of the stocking rates for the predator and the various prey species that you might put in the pond, but the harvest must also be balanced. Stocking is balanced and harvest must also be balanced between the predators and the prey, whatever the actual species might be. All right, so since we're on this subject of trophy management, I wanted to just, as a reminder, mention a couple of other extremely intensive aspects of management that have developed in recent years. If you're really trying to push a pond to get maximum intensity or maximum production, and there are a lot of different ways to do this, but in terms of recreational pond management, one of the ways is to actually guarantee that water quality conditions are going to be maintained through the growing season in a desirable way. And I hesitate to use the word aerator here, but obviously the higher the productivity of a pond, the higher the demand for aeration of one sort or another. And they're both natural and artificial aeration types. But pond destratifiers are becoming more popular in extremely intensive pond management. They basically provide mixing and prevent stratification, and during the growing season of the pond, they allow conditions to be maintained at a higher level. And they're also, in some cases, considered sort of an insurance policy. If you're going to put all this effort into management, if you're really going to maximize your potential for producing trophies, these pond destratifiers are becoming more popular in terms of making sure that we don't have problems and catastrophic losses of our investment. Another mechanism for increasing intensity of management, but increasing the natural productivity of a pond, basically involves feeding the fish on artificial food. And artificial feeding can dramatically increase the productivity of a pond in a couple of different ways. Obviously, the fish benefit from directly consuming the fish food. And again, we typically use commercial pelletized fish foods, but you also get increases in the primary productivity because of the fertilizer effect of the addition of this fish food, either directly or indirectly for the fish in the pond. So those two, the aeration / destratification and fish feeding, can drastically increase your production, but they also dramatically increase your expense and increase the level of intensity of management. All right, so shifting gears here, I want to talk a little bit in detail about aquatic plant management. I already mentioned that some things are good and desirable and necessary for healthy ponds. Other things undesirable. That's where the good, the bad, and the ugly comes in. And some things are just flat out dangerous when it comes to aquatic plant management. So I want to remind you of this whole idea of that little equation of if there's light, if there's nutrients, and there's optimum temperature, then something's going to grow. And it's just a matter of what might grow. But if it is, in fact, undesirable aquatic species of plants, especially the invasive exotics, again, I'll refer you back to this resource. The Regional Aquaculture Center is a good online resource. And on the Regional Aquaculture Center web pages is a link to a lot of information on a lot of topics. But one of those topics is aquatic vegetation control. And so if you were to go to the aquatic plant or the aquatic vegetation control section at the Regional Aquaculture Center website, you'll see a list of fact sheets on specific aspects of aquatic plant management. And one of those that is quite useful is the information about the use of aquatic herbicides. Again, not all plants are bad, but when we have invasive exotics in particular, this is a good resource. If you click on this website, you'll see that you can download this document that discusses aquatic plant management in a good bit of detail and talks about the specifics of what herbicide works well on what plant, and that can be very useful. And again, this is all the labeled aquatic herbicides, the brand names, and the active ingredients for what's available here in the throughout the United States. If you're in one of the states where grass carp are used for aquatic plant management, there's some information on grass carp use, and all of this can be helpful in terms of getting the details on aquatic plant management. Very quickly, a few other resources for aquatic plant management. Obviously, your local county extension agent is a very good resource when you have questions about aquatic plant management. In a second, I'm going to show you a website that has a nice interactive link for aquatic plant management questions. And then also, when things get complicated, or it can be potentially risky with the use of certain types of herbicides, and you may choose to consult a professional, a fisheries consultant. And I got to give an endorsement to Owen & Williams Fish Farm, which is a local fisheries consultant, because they provided me with these pictures of the great big fat bass that I showed you earlier. But one online resource that for the do-it-yourselfers, if you will, is this Aquaplant, a pond management diagnostic tool. The link here will bring you to the Aquaplant web resource, where one important thing I wanted to point out here was that there's a very useful photo-based plant identification resource, and identifying aquatic plants is extremely important. Misidentification of aquatic plants is really easy. It's easy to make mistakes. Those mistakes can be extremely costly. You're paying a lot of money for an herbicide or some other type of treatment, and it's ineffective. Then obviously that's very undesirable. So if you're not absolutely sure, then use one of these other resources to make absolutely sure that you have identified the plants accurately. And then once they've been identified, this interactive website can walk you through various management options that might be available. So next I want to talk just briefly about water quality. Water quality is in its simplest terms, are defined as all of the physical, chemical, and biological properties of water which regulate its use. And for our purposes today, the fish are our use. So our goal is to keep fish happy and healthy and reproducing and growing well. And so it's important to understand the properties of the water and in order to do that. One really good resource for understanding that, in almost every state, there is available, either privately or publicly, a lab that will do water testing. And this is just a link, an example link to the University of Georgia Ag and Environmental Services Lab. This is one source of most universities have an environmental services lab that can do water testing. And that information can be very useful in terms of understanding what we're working with in terms of either the source water if we're building a new pond, or the existing conditions in water if we're managing a pond. And again, I'll turn you back for additional information to the Southern Regional Aquaculture Center website. And if you go to this link, there's one particular fact sheet that I would recommend you download. And the reason is that it is entitled Interpretation of Water Analysis Reports. So once you get this useful water quality information, how do we know what's right and what's wrong? Well, this publication was prepared. We prepared this in order to try to answer some of those questions. It tells you how to submit your samples. And then, most importantly, it talks about the desirable and the acceptable ranges for the various water quality parameters that you might measure. So this is a really good way to get a feel for the conditions in your pond or the source water that you're going to use for your pond. So in summary, we've kind of touched in a very generic way on the subjects of pond construction and renovation, hopefully giving you some resources to go home and do some homework on. We talked a little bit about fish ecology in a general sense, so that hopefully you can apply some of this to the regionally specific conditions for a pond that you're interested in. I talked a little bit about aquatic plant management and hopefully gave you a few resources to go home and investigate. And then finally did the same on water quality management.
It's been a real honor having you here, Jay. Appreciate it. Thank you all for coming today.